Alright, let's work through this geometry problem carefully, because the diagram looks complicated at first, but there is one very important similarity relationship that makes the whole problem fall into place. We have a square, PQRS, and inside it we have the blue region, TURS. Point T lies somewhere on the left side, PS, and point U lies on the top side, PQ. We're told that TU has length 15 units, UR has length 60 units, and most importantly, angle TUR is exactly 90 degrees. Our goal is to find the exact area of the entire blue region. So, let's start by introducing two variables that will make the relationships much easier to see. Let the side length of the square be x, and let the small top segment, PU, be y. Since PQRS is a square, all four sides have the same length, so PQ, QR, RS, and SP are all equal to x. Now let's focus our attention on point U. We know that the top side PQ is a straight line, so the angles along that straight line add up to 180 degrees. At U, the angle inside the blue triangle TUR is 90 degrees. That means the two remaining angles formed above the blue region must together add up to another 90 degrees. Let's call those two angles alpha and beta. Now, why are we doing that? Because these angles allow us to compare two triangles that may not look obviously related at first. Look at the small white triangle PTU on the left, and then look at the white triangle UQR on the right. Both are right triangles because PQRS is a square. At P, the angle is 90 degrees, and at Q, the angle is also 90 degrees. At U, the angles alpha and beta appear on opposite sides of the same straight top line, and because the blue angle between UT and UR is 90 degrees, alpha plus beta must equal 90 degrees. Therefore, the acute angles of these two white triangles match. So the two triangles PTU and UQR are similar. This is a really important moment because similar triangles have proportional corresponding sides. In other words, if one triangle is a scaled version of the other, the corresponding side lengths have the same ratio. In our smaller triangle, the side PU has length y, and the hypotenuse TU has length 15. In the larger triangle, the corresponding side QR is the side of the square, so its length is x, and the corresponding hypotenuse UR is 60. Therefore, we can write the proportion x divided by 60 equals y divided by 15. Now let's solve that carefully. We have x over 60 equals y over 15. To eliminate the denominators, we cross-multiply. That gives us 15x equals 60y. Now divide both sides by 15. Since 60 divided by 15 is 4, we get x equals 4y. This is a very useful relationship. The side of the entire square is 4 times the little segment PU. So, keep that result in mind. X equals 4y. Now let's look at the entire top side PQ. Its length is x. We already know that the first portion, PU, has length y. So the remaining portion, UQ, must be the entire top side minus the first portion. In other words, UQ equals x minus y. But we already discovered that x equals 4y, so substitute 4y for x. That gives us UQ equals 4y minus y, which simplifies to 3y. So, now we know something very nice. The two legs of the larger right triangle, UQR, are 3y and 4y. And what is the hypotenuse? That is UR, which we are given as 60. This is exactly where the Pythagorean theorem comes in. Remember, for any right triangle, the square of one leg plus the square of the other leg equals the square of the hypotenuse. So for a triangle UQR, we write 3y whole squared plus 4. Y whole squared equals 60 squared. Now simplify each part. 3y whole squared becomes 9y squared, and 4y whole squared becomes 16y squared. 60 squared is 3,600. Therefore, we have 9y squared plus 16y squared equals 3,600. Combine the like terms on the left. 9 plus 16 is 25, so we get 25y squared equals 3,600. Now divide both sides by 25. That gives y squared equals 144. Taking the positive square root, because a length cannot be negative, we get y equals 12. So our small top segment PU is 12 units long. Now we can find the side length of the square. Remember our earlier relationship, x equals 4y. Substitute y equals 12. So x equals 4 multiplied by 12, which gives us 48. Excellent. We now know that every side of the square has length 48 units. At this point, we are very close to the area, but we still need the vertical height of the lower blue triangle. Before we calculate the blue area, let's split the blue region into two simpler triangles. The upper blue portion is triangle TUR, and the lower blue portion is triangle RST. This split is useful because both pieces are triangles, so we can use the familiar area, formula 1/2 multiplied by base multiplied by height. Let's first find the area of triangle TUR. We are told that angle TUR is 90 degrees, so TU and UR are perpendicular. That means we can use those two given lengths directly as the base and height. TU is 15 and UR is 60. Therefore, the area is 1/2 multiplied by 15 multiplied by 60. First, 15 multiplied by 60 is 900. Half of 900 is 450. So the area of triangle TUR is 450 square units. Now we need the area of the lower triangle RST. Its base is RS, which is one side of the square. So we already know that RS equals 48. But we need its height, which is TS. To find TS, let's go back to the small white triangle PTU. We already know PU equals 12 and TU equals 15. Triangle PTU is a right triangle because the square has a 90-degree angle at P. So we can once again use the Pythagorean theorem. Let TP be the unknown vertical segment, then TP squared plus 12 squared equals 15 squared. Now calculate the known squares. 12 squared is 144 and 15 squared is 225. So we have TP squared plus 144 equals 225. Subtract 144 from both sides. This leaves TP squared equals 81. The square root of 81 is 9, so TP equals 9 units. Now remember, the entire left side PS of the square is 48 units. That entire side is made up of PT plus TS. We have just found PT equals 9. Therefore, TS equals 48 minus 9, which is 39 units. That gives us exactly the height we need for the lower blue triangle. So now, look at triangle RST. Its base RS is 48, and its perpendicular height TS is 39. The area formula for a triangle is 1/2 multiplied by base multiplied by height. Therefore, the area of triangle RST is 1/2 multiplied by 48 multiplied by 39. Half of 48 is 24, so this becomes 24 multiplied by 39. Calculate that carefully. 24 multiplied by 30 is 720, and 24 multiplied by 9 is 216. Add those together and we get 936. So the lower blue triangle has an area of 936 square units. Now we simply combine the two blue pieces. The upper triangle has area 450 square units, and the lower triangle has area 936 square units. Therefore, the total blue area is 450 plus 936, which equals 1,386 square units. And there we have it. The exact area of the blue region is 1,386 square units. Notice how the problem initially gives us a fairly intimidating diagram, but the 90-degree angle creates a similarity between the two white triangles, and that similarity gives us the relationship x equals 4y. From there, the 3 to 4 relationship appears naturally. The Pythagorean theorem gives us y equals 12. The square side becomes 48, and finally, we use two triangle areas to reach the answer. If this step-by-step approach helped you see how the hidden structure works, make sure to like the video, subscribe for more challenging geometry problems, and leave a comment telling me whether you noticed the similar triangles before we started calculating.